Hello everyone, my name is Arpan and I am going to discuss the topic the Hough transform for detecting lines in images. This is the table of content in which we will be going through the introduction, working of Hough transformation, edge images, canny edge detector, image and Hough space. Then after we will see the mapping of edge points onto the Hough space and algorithm for detecting lines using Hough transform. We will be seeing some applications and future work. Now coming to the introduction slide, we are going to know what Hough transform is. Basically, Hough transform is an algorithm which is used for extracting features from the image such as lines, circles, outlining, boundaries, corners present in the image. It is used in image analysis, computer vision and digital image processing. It is also used to find imperfect instances of objects within a certain class of shapes by a voting procedure. For example, if we are given an edge which is a straight line and that line is not continuous, there is break, this Hough transform is going to help us to find out the continuous line. It was patented by Paul V.C. Hough in 1962. Since its beginning, it has gone through many changes and it was brought into image analysis by Rosenfeld in 1969 and applied to the detection of lines and curves in the digital picture in 1972 by Duda and Hart. Now for understanding the Hough transform working, we need to have some ideas and knowledge about the four basic concepts which are edge image, the Hough transform and the mapping of edge points onto the Hough transform. That means what is Hough transform and how we will map the edge points onto the Hough transform. We will learn this in the further slides. And the third requirement is an alternate way to represent a line, that is the parametric representation of a line or the normal representation of line. And the fourth concept is the line detection. Edge image, and edge image is the output of edge detection algorithm. Since an edge is in an image is a sharp variation of the intensity function, so using edge detection algorithm we can detect edge in an image by determining where the brightness or intensity of an edge of an image changes drastically. Some of the edge detection algorithm are canny, Sobel, Laplacian, etc. We are going to see canny edge detection algorithm in our further slide. Canny edge detector. It is one of the most strictly defined method that provides good and reliable detection because it meets all of the three criteria for edge detection, like detection of edge with low error rate and the edge points detected from the operator should accurately localize on the center of the edge, and a given edge in the image should only be marked once, that is, and image noise should not create false edge. It is a multi-stage algorithm to detect the wide range of edge in an image and was developed by John F. Canny in 1986. This edge detection technique extracts useful structural information from different vision objects and dramatically reduce the amount of data to be processed. It has been widely applied in various computer vision systems. Uh, Now coming to the image space and Hough space. This figure shows the image space representation. In this, an edge is represented as a line. Let's it's a this is a line form. uh, the equation of this line form is y equals to mx plus c. This is which is which is represented as line in image space. If we represent this is in half space, in which the x-axis represents the intercept and y-axis represents the slope, it will be represented as a point. This half space is a 2D plane that has horizontal axis representing the intercept, or it may be it can be slope, and the vertical axis can be slope or intercept. A line in an edge image is represented in the form of y equals to ax plus b or y equals to mx plus c, where a or m is the slope and b and c is the intercept. From this figure we can clearly see that one line in the edge image produces a point on the half space. On the other hand, an edge point on the edge image can have infinite number of lines passing through it. Therefore, an edge point produces a line in the half space, which we will see in the further slides. As an edge point xi yi on the edge image can have an infinite number of lines passing through it. Therefore, an edge point produces a line in the half space in the form of b equals to ax I plus yi. This half space is used to determine whether a line exists in an edge image. Now coming to the alternate representation of line. Here we are going to see the normal representation of line. In the previous slides we learned that the equation of line is equals to is y equals to mx plus c. But that representation of line has some drawbacks, because of which we are going to the parametric representation of line. In that form of line, we have for vertical lines the slopes become infinite. That means that a computer would need an infinite amount of memory to represent all possible values of the slope. To avoid this issue, this straight line is instead represented by a line called normal line that passes through the origin and perpendicular to that straight line. This form of line is represented as rho equals to x cos theta plus y sin theta, where theta is the angle between the line and the x-axis, and rho is the perpendicular distance of the line from the origin. This line, in its corresponding half space representation, it will produce a cosine function instead of a straight line. Process of line detection. In the process of line detection, we first provide input image, which is the original image in which we want to detect the lines. Then after, the output of this edge detection is the edge image, where we clearly see that there is only one straight line, and this is the Hough space. These sharp points represents the intersection points of two or more lines or edges, and then after, the output of the image is the detected lines. This is the algorithm for detecting lines using Hough transform. In this algorithm, we first load the image, then determine the image edges using any edge detector like Canny, Sobel, Laplacian, then quantize the parameter space. The image space is quantized. This quantized space is known as accumulator cell. It holds the parameter rho theta. This accumulator cell, in this accumulator cell, the rows represent rho and the columns represent theta. The value of the accumulator cell is set to 0 initially. The Hough transform checks the image x and y coordinates and calculates the corresponding rho theta pair. For a calculated rho theta, the value of that particular accumulator cell is increased. Shows the Hough transform, find the local maxima in the parameter space. The lines are found at the peaks of the accumulator space, and then after, it's draw the line using the local maxima. Now coming to the applications, it is widely used in feature extraction like shape of the objects, like lines, circles, etc. Another important advantage is used for building edge extraction. It also extracts the lines even through the noisy data. Using Hough transform, we can detect the missing lines which are broken while detecting edge image. We can use it in a lane detection of the road also. Coming to the future work, to improve the speed and efficiency of the algorithm, these are the areas where we need where another source of error, and another area is in extending the Hough transform to detect other geometric shapes, at its only used to use in line detection, circle detections, any